providers as well as other organizations that these automation backends want to be exposed somehow as well. The platforms we are building, they vary across infrastructures. Some clients, they do have a contract with Amazon and they do Amazon all-in, others do Azure all-in, some do multi-cloud, some do hybrid clouds, some are basically entirely on-premise. And whatever automation we build, and this applies to Klutch as well, it must work in an infrastructure-agnostic way. So we are dealing with application developer platforms that have, thousands of applications and hundreds to thousands of application clusters. So large organizations with a lot of developers. And last time, I checked, if you have thousands of applications, they usually depend on thousands of data service instances. And at the same time, if you do that at scale, so let's say you run 3,000 Postgres databases, which we do for our clients. And now there's a vulnerability, either down in the Linux stack or in the database itself, and you need to turn over 3,000 database instances. Well, you got to be prepared for that. You got to find out where are those databases, who is in charge of those databases, because it's on-demand self-service for developers, which means that actually it's the application developer who triggers the button if it's, let's say, a major release that is being updated. For patch levels, you couldn't get around this, but you need some sort of central registry where you know where all the service instances are, and this must be somehow done. And as I said, 40,000 virtual machines with 10 DevOps, that's already a lot of assets under management per DevOps, so you need a high operational efficiency to get there. So as the Kubernetes ecosystem is omnipresent, we also want to build this in a Kubernetes-native fashion, as Kubernetes also becomes the sort of standard way on how to expose any cloud service these days, with its declarative nature, obviously in working as, let's say, it resonates very well with the declarative nature of our automation that we've built many years before as well. And Klutch leverages the power of Crossplane, because if you think about how you expose backends, it basically, and you want to make it in a Kubernetes idiomatic way, at some point you have an external non-Kubernetes resource or a Kubernetes resource, and you want to reconcile that into some state. So there are a lot of providers already there for Crossplane, so why not use that and leverage that? So this is all being the case. So one of the pieces of, or one of the motivational factors we had was that, the elephant in the room for modern application platforms is not necessarily Postgres, but it's the cloud service challenge, which means if you have 1,000 apps, right, you have container orchestration. Well, whether you use Kubernetes or whether you use Cloud Foundry, your apps are taken care of. There are standardized ways on how to deploy apps, and it's usually not the big problem of building a platform. But where do you get your data services from and how they are managed? That's when things get ugly. That's what we call the data service or cloud service challenge. And especially when talking to Kubernetes folks, and you're at a Kubernetes conference, which we are not exactly here, but the first idea people say is, why not put everything on Kubernetes? Kubernetes is wonderful. Why not put everything on Kubernetes? And we've seen customers trying to do that. To me, the idea of local operators is kind of problematic, because you will be ending up asking yourself, are you looking for developers or unicorns? And what I mean is, if you operate everything in an application system needs within a Kubernetes cluster, including the databases, then the developers in that team need to be really, really well trained, and they need to acquire a lot of skills. A database is not a trivial thing to run. And if you have multiple databases, then that multiplies the effort and knowledge that must be present. There are organizations where this is no problem. They have the skilled people. Well, then go for it. However, if you basically scale that and you take that to larger scales where you multiply that pattern, think of the resources the operators will consume as you also multiply the automation itself. But also think about the skills each developer team will need in order to make this a reality. When this can be efficient. And I'm pretty sure you won't get to the 4,000 managed assets per DevOps as compared to having data service automation separate from application operations. So instead, what you can do is separate the automation from the application clusters, but then you have to solve the challenge on how to get, let's say in this case it's a pure Kubernetes environment where the application developer wants to use Kubernetes to deploy both the app as well as the database. So how would you declaratively describe, I want a database, and then have some other remote place where the automation takes place without creating another problem, which would be integrating an automation backend directly in the application cluster, because that doesn't scale as well. Then you won't have that central governance, you won't have that central registry, and when security comes and asks, well, where exactly do we have Postgres 14.0.5 instances? Nobody would be able to tell. So we believe that we take things that we've learned from the Cloud Foundry community and translate it into Kubernetes-native interface, and that's basically what Klutch does. So in a nutshell, and I have to rush through this a bit, in a nutshell, what you do is you separate the automation backends from the application cluster where your applications are basically located, and you install a lightweight extension to those application clusters, the Klutch client. Whereas there's also a Klutch server where the integration with the actual automation backends takes place. So these local extensions, they will give the Kubernetes developer the extension to the local Kubernetes cluster. I mean, you can extend the Kubernetes cluster with operators, and you'll have custom resource definitions for service instances, service bindings, and backup, restore, and backup plans. So providing you with the tooling as an application developer to create a database instance, that will be reconciled. All the objects created in application clusters are replicated automatically to the Klutch server, and that one then reconciles with the actual automation backend. And that leads to the situation that any developer can describe the entire application system, the database, the application, and with service bindings, the connection of the database instance with the application, declaratively and natively in Kubernetes. So there's a control plane as it's a client-server model. There's a lightweight connector, which does nothing but proxy, representing objects that will be replicated to the Klutch server who will actually reconcile to the automation backends. They're written in Go. And the idea is to keep the service instances at a separate place. And you can have multiple of those backends. You can integrate any data service, any cloud service you want. Or you could have multiple flavors. For example, we have a pod-based Kubernetes operator for Postgres, but we also have VM-based virtual machine automation for Postgres. So you could choose which one to use. And as I said earlier, it's using Crossplane to leverage the power of integrations that are already there for writing the integration, not for writing the automation backend. Could potentially do that too, but most of the time there's already some sort of automation present. So as I said, because this is a Kubernetes workload and because you're basically allowing any integration so an integration, what does it mean? It means you have to somehow define what a service instance is, what a service binding is, and how a backup and restore works. So for Postgres, a service instance is creating the actual database cluster. A service binding is creating a database user, which will also create a secret in the local application cluster. And backup and restore, well, that's kind of self-explanatory. So this is what you have to do in order to create an integration with Klutch. And you can use Crossplane to do that, which should make it fairly easy. And once you've done an integration for a service, you can expose it through Klutch wherever you want. So I'm using here as an automation backend our own Postgres, which uses BOSH as an infrastructure abstraction layer and does on-demand provisioning of dedicated virtual machines upon a user's request. This is our automation backend in this case, and because it can be applied to all the infrastructures, you can use them across all the infrastructures, whether this is OpenStack or VMware. Now, if you go to public clouds, you would see that there are already Postgres offerings there, and you can integrate them with Klutch too. So if you don't want to have, let's say, our Postgres or somebody else's Postgres operator, you can use Amazon RDS and integrate it with Klutch too. And why would you do that? If you ever try to deploy an app, including a database, from within a Kubernetes cluster, based on, let's say you go to Amazon, create an EKS cluster, try to create a database. It's a horrible user experience. You have to step outside of Kubernetes. You have to get yourself into how to create an IAM user, how to create an RDS instance, how to create a policy. It's not exactly a self-service in the sense that we would expect it from the perspective of a cloud foundry user. And Klutch is bridging that gap. It provides self-service to application developers who don't want to have the power of an Amazon account, because you need to train people with Amazon tooling too. And if you then go to Azure, things work differently. Not with Klutch. It's the same abstractions present across all those infrastructures. And you can create thousands of application instances and manage them, using your own integrations if you like. So in this example, you can see how to develop a large-scale developer platform across various different clouds, using the databases provided by the infrastructure vendors, and have a relative homogeneous user experience for the user. Well, if you get to document databases, this is where this picture falls apart to some degree, because yes, it will be similar to create the application instance, but the application will still have to make sense of the document database, which will be different on all those different platforms. So there's the underlying heterogeneity of infrastructures. So the developer perspective is, as I said, you have those basic abstractions for every integration, which is a service plan. It's a t-shirt size, so to say. Let's say Postgres with asynchronous streaming replication, set up with a default set of plugins, and 32 gigabyte of memory, and 500 gig of storage. So that's a service plan. You make those t-shirt sizes that are most popular within your organization, and therefore also be able to provide well-tested configurations so that application developers don't have to care. Then you create a service instance as a developer, which is the actual database. Create a service binding, which creates a secret and a username password combination over at the service instance. So all your application has to do is read the secret and access the database. So these abstractions actually then are exposed through the Klutch client in the application cluster. So you use standard Kubernetes YAML to basically create your own database. And as you can see in those two examples, this one is creating pods at a remote Kubernetes cluster. And this one is creating virtual machines that run someplace else. And as you can see in the simple example, it's basically looking the same. Creating a document database, no problem, also looks the same. Well, if you get into the details, there will be configuration parameters that will be specific to the backend, so the generalization only goes so far. But with the service plan, you already hide a lot of those configuration items so that this will actually remain often very similar to each other, which also means you have a high reusability within your CI/CD tooling because this is relatively uniform. Service bindings, same thing, different data structure, but it's the same idea. You have a spec. And last but not least, let's see how far we go. This is how you would use it. So if you're not so familiar with Kubernetes, or if you use Kubernetes, you can basically write such a YAML file, which represents your declared or desired state. You would do that in a GitOps manner, maybe, having this in version control. Here you create a service instance referring to the service plan single medium, so single pod or single VM. We're using the AWS Postgres pod and backend, which creates pods. So this would be a Kubernetes operator sitting someplace else. Different Kubernetes cluster where data service operations are centralized. And then you just apply it, and your database will be created for you. So next thing you usually do is you want to check whether the service instance has been created. And then your application binds to the service instance by creating a so-called service binding. This is basically creating a database user and a local Kubernetes secret. This is where the credentials are stored, and you can reference that in your application manifest. And that's basically how simple it is to consume a database from an application cluster. While all this information, where are the databases, is stored on the central Klutch cluster, so that if you have 1,000 application cluster or 500 application clusters, the security officers or the platform operations team would always know where are the service instances and what version are they, what is the desired state of each service instance, when has a particular backup been created. So this is basically Klutch in a nutshell. In single words, it separates the data service automation backend from the application clusters while providing you with central governance and allowing you to integrate basically any cloud service there is. Now, as I said, this is open source, which means the empire wants you, in the sense that, touch the clutch, touch the clutch, I think is the motto here. You can try it out yourself. If you like it, you can give it a star on GitHub. We're currently working on a self-demo where you can simulate multiple Kubernetes cluster using Minikube and Kind. You can use our commercial AWS Postgres operator for free for the purpose of non-commercial and local work. So to try out having a separate Kubernetes cluster, having Klutch and an operator put in a different Kubernetes cluster, and try out the user experience. So with the idea that if you ever work in a larger organization where this sort of separation of concerns is useful, you can use Klutch. We also do demos, live demos, if you want that. And because this is early stage, this is all implemented, it works, but we're also giving free POCs away. So if you like the demo and you want to try it out in your organization, we'll put it on your infrastructure and help you get it running and take it from there. So if you don't want to get involved with us because you hate people and you'd rather stay with your laptop, I'm a computer scientist myself, right? And I hate nothing more than sign up forms or anything where, get my email address and my name to download this. No, just let me download it and try it out myself. You're free to go to do that. I'm not sure how we caught up with documentation. Documentation was a bit lagging behind, but I think we are releasing a new version of documentation as we speak to also incorporate the self-demo. So it's either happening already or it's happening in a couple of days or a couple of weeks. Yeah, that's it in a nutshell. Hopefully I got the points across. So 20 minutes is a bit short on time, but if there are questions, feel free to ask. Otherwise, I'll be around and you can catch me later. But I think we have a few minutes, right? Yes. We looked at open source operators at the time. The most promising was the Zalando operator. But because we want to expose on our operator level already service instances and service bindings, the Zalando operator and backup and restore resources, the Zalando operator did not really match our requirements, and we basically wrote it from scratch. However, we are using the Spilio image and the Patroni a cluster manager. In our VM-based version, we are using Web Manager, I think, for cluster management. But in the future, we are open to integrate with other commercial vendors as well. What is the comparison, Zalando versus? Well, if you ask me, do you want to run a database on a VM or a pod, you got a story started. It could go on forever. Personally, I believe that this sort of automation, where you have an organization, you want to create thousands of databases. What kind of database do you put on an automation like that? Yeah, it's not the central database of your organization. It's assuming that you have 1,000 databases. They're all somehow important. They all need to be taken care of in a particular way to comply to what not, security standards you have to fulfill. But you cannot possibly do this in a semi-manual DevOps mode anymore. This is when you use this sort of automation, and this is also when you accept a certain performance drawback through the separation of the ephemeral compute from the persistent disk or persistent volume, for example. And my fear about pod-based automation is less about performance, it's more about noisy neighborhood issues. And therefore, we still develop, and our majority of backends that we own and serve and license to our clients is VM-based. And here we use technology from the Cloud Foundry ecosystem called BOSH, which in my opinion is the most underrated automation technology of the past decade. Because it basically does what Kubernetes does, but to VMs, in an infrastructure operating system independent manner, where you'd, be using Ubuntu in the end, but infrastructure argument is very important, and it's declarative. So I would say a VM is a good thing for data services. However, try to recruit people who will write BOSH automation. You will have to recruit them, and you have to teach them how to do BOSH automation, whereas with Kubernetes, you can pick them up from any corner. So in this regard, we are actually adding new data service based on Kubernetes. Not because Kubernetes is better, but Kubernetes is, just from the business perspective, more sustainable. All right. As I said, I'll be around. Just if there are any further questions, reach out, grab me. I'll be happy to talk.